All right, guys, welcome to today's session on creating data repositories for machine learning. This is a crucial topic because in the world of machine learning, your model is only as good as the data it learns from. So today we will explore how to identify data sources, determine appropriate storage mediums, and build a solid foundation for effective machine learning solutions. So, whether you are a learning ML engineer, a data scientist, or an aspiring cloud architect, uh, and if you're about to take uh, MLS C01 AWS Certified Machine Learning exam, uh, this uh, this session is for you. This is going to address task one of domain one. So, a data repository is essentially a centralized place where data is stored, managed, and retrieved for analysis and machine learning purposes. It can take many forms: cloud storage, relational databases, data lakes, or distributed file systems. So, the goal of a repository is to provide a scalable, secure, and accessible storage for different types of data sets that machine learning models need to train, right? Train on, they validate, and also infer predictions from. So, before setting up a data repository, the first step is understanding where your data is actually coming from. That brings us to the next topic: identifying data sources. The success of a machine learning model hinges on high quality data. But where does this data come from? Let's break it down into key sources, right? So internal sources of data be like, would include customer database records of user interactions, purchase history, customer support logs, right? uh, Operational data logs from applications, sales reports, and financial transactions. You would have employee data like HR records, training logs, and productivity metrics. Uh, and external sources would include, sometimes, web scraping, for example, collecting data from publicly available websites or social media feeds or online marketplace. And then there are third-party APIs, right? Using APIs from Google, for example, AWS, Twitter, Open Weather, and other platforms. And open data repositories, so data sets from sources like Kaggle, Google datasets, and open data. For real-time ML applications like predictive maintenance, fraud detection, and self-driving cars, streaming data from IoT sensors is crucial, right? So the example would be like manufacturing sensors, monitoring machine performance and predicting failures. Smart homes and wearables, right? Collecting data from fitness trackers, smart thermostats, or security cameras. And then financial transactions like processing real time banking and e commerce transactions. So, with data sources identified, the next step is to determine the best storage solution for your ML workloads. So, selecting the right storage medium depends on several factors, okay? Scalability, performance, security, and cost. All right, so let's explore the best AWS storage options for machine learning data repositories. So Amazon S3 is the go-to for data lakes in Amazon, right? Amazon S3 is one of the most widely used storage services for machine learning workloads, and it provides, unlimited scalability. It stores petabytes of data with ease, right? And flexible data formats, like it supports CSV, JSON, semi-structured like Parquet, Avro, and unstructured images, and data. And it integrates with machine learning tools like works seamlessly with AWS Glue, uh, SageMaker, and Athena for querying and processing. So S3 is perfect for building a data lake where raw, processed, and refined data sets can coexist for different machine learning workflows. So, if your model requires structured relational data, Amazon RDS or Relational Database Service and Aurora are excellent choices. Their use cases, would include like transactional data, banking, financial services, healthcare records, or CRM for storing customer interactions and preferences. And historical data analysis, like retaining structured data sets for model training and analytics. RDS supports MySQL, PostgreSQL, and SQL Server, which makes it a strong candidate for traditional machine learning use cases. For large scale data analysis, Amazon Redshift provides a high performance data warehouse optimized for querying structured data sets, right? It's used for business intelligence dashboards, for aggregated reporting for machine learning models, and handling petabytes of structured data with optimized query speeds, right? So Redshift is ideal for machine learning models that require frequent querying and processing of large data sets. All right, some machine learning workloads and need file storage rather than object storage, right? That's where Amazon Elastic File Systems and Amazon FSx come in. So Amazon EFS is a fully managed file system that scales elastically. It is ideal for workloads that require shared access across multiple compute instances. Okay. And then Amazon FSx for Lustre is optimized for high performance computing with machine learning workloads that need low latency file access. So if you're running ML on high performance clusters, FSx can provide fast storage for training deep learning models. For applications requiring fast, low latency access to data, Amazon DynamoDB is a NoSQL database that supports real-time machine learning applications, recommendation engines, right? Uh, and user session data storage. So DynamoDB is best when dealing with key value or document-based storage rather than a structured relational database. An AWS Glue catalog isn't a storage medium itself, but it plays a critical role in organizing and discovering data stored in various locations, right? So it indexes metadata across S3, Redshift, RDS, and more. It integrates with Athena for SQL based querying and supports schema evolution for data transformation and workflows, right? So this tool is crucial for managing large-scale machine learning repositories efficiently. And for this exam, you should definitely pay attention to AWS Glue. So choosing the right storage medium depends on several factors. Let's discuss the key considerations, all right? Scalability, I would say. So, can the storage solution grow as the data set expands? S3 and Redshift are great for scaling large ML repositories, all right? Then, cost. What is the total cost of storage, data transfer, and processing? Object storage like S3 is cost effective, whereas EBS and RDS can be more expensive. Okay. And then performance, right? Does the ML workload require high speed read write operations? If so, FSX and EBS might be better suited than S3. Okay. And security, right? Data security is, of course, paramount, especially for sensitive data sets. So AWS provides encryption, IAM based access control, and compliance support for different storage solutions. All right. Scalability, definitely. So the question you should ask is, can the machine learning services like SageMaker easily access data? So S3 is natively integrated with AWS ML services, while Redshift requires JDBC or ODBC connections. All right, so now that we've explored the storage options, let's discuss best practices for managing data repositories efficiently. Okay, so definitely use data partitioning. It improves query performance by splitting data into smaller segments, and optimize storage costs. Right, use Amazon S3 lifecycle policies to archive infrequently used data. Right, and ensure data security by enabling AWS IAM roles, encryption, and VPC endpoints for secure data transfer. And automate data pipeline, right? Use AWS Glue, Lambda, or step functions for automated data ingestion and transformation. And monitor data regularly, right? Check for missing values, duplicates, and inconsistencies before training models. So, to summarize, creating an effective data repository for machine learning involves data sources, selecting the right storage solutions, and ensuring scalability, security, and cost efficiency, right? And AWS provides a range of services from S3 for data lakes to Redshift for analytics that cater to different machine learning storage needs, right? So, with a solid data foundation, you can build more accurate, reliable, and efficient machine learning models. Thank you for your time, and I look forward to your questions and also in the next session.